Good afternoon, my YouTube viewers. Crystal here. I'm just here because I wanted to make another video for you. What I wanted to do is I wanted to show you how to create a graph of the E. coli imbalance dataset in 3D. So in previous video, I showed you how to do it in 2D. Well, now I'm going to show you how to do it in 3D. So what we'll do is we'll go over a code review for what I did in that area. So the first thing we did is we used the E. coli dataset, and we're going to use principal component analysis. So I'll read you the first few sentences of the information on the E. coli dataset. The E. coli balanced dataset describes the problem of classifying E. coli proteins using their amino acid sequences in their localization sites. That is, predicting how a protein will bind to a cell based on the chemical composition of the protein before it is folded. The dataset is credited to Kenta Nakai and was developed into its current form by Paul Horton and Kenta Nakai in their 1996 paper entitled A Probabilistic Classification System for Predicting the Cellular Localization Sites of Protein. In it, they achieved a classification accuracy of 81%. The dataset is comprised of 335 examples of E. coli proteins, and each example is described using 7 input variables and calculated from the protein's amino acid sequence. And then so the rest of it, they give you information about the proteins and amino acids, and they also give you information about the 8 classes. So the first thing we did was we created a program in Google Colab because that's my Jupyter notebook of choice. It's a good Jupyter notebook because it's done offline and the libraries are already imported into the Google Colab, so I do not have to worry about importing libraries or checking to make sure I've got the latest editions. And then what we're going to do is we're going to load the data set. And when we load the data set, they didn't have the column headers, so I had to put the column headers in there. If I didn't put the column headers, then one of the columns would have showed up as a column header, and we definitely didn't want that. So we check for any null values, and in this instance, there's not any null values, which is a good thing. And then we import collections so we can count how many of the 8 classes that we have. And 2 classes, we have only 2 examples, and 1 class, we have 5 examples. So that presents a very major class imbalance that needs to be overcome. And so far, I haven't been able to overcome the class imbalance. So what we're going to do now is we're going to define the features. And so the features are going to be the columns. So features equals train columns. And then what we do is we define X and scalar. So X equals train dot result, axis equals 1 dot values, X equals standard scalar fit transform in X shape. So it's 335 and 7 columns. And then what we do is we get the mean and the standard deviation. And then after that, what we do is we define our features, and our features are actually the columns. So we normalize the data, and so the normalized data is actually the standardized data. And the feature columns are the features. Then what we're going to do first is we're going to create a 2D model. So we're going to import the PCA, that's principal component analysis, and we're going to set the end components up for 2. So what that will do is that will allow us to create a 2D diagram. And then we're going to fit the principal, we're going to fit it into X. because principal component analysis is a type of unsupervised learning, and you have to fit it and transform it. So we've got our principal component analysis DF, which is a data frame, and we've got 2 columns. So we've got principal component 1 and principal component 2. And then what we're going to do is we're going to make our 2D diagram using a formula. I got the formula from the IRIS dataset, but I modified it on sklearn, but I modified it to put all of the 8 classes of the E. coli dataset in there. So now you see our 2D diagram. So you can see the 2D diagram and how all of the different examples are interspersed. And then because all of the examples are interspersed, it's a bit difficult for the computer program to pick out one example. I'm thinking it would be easier for them to pick out an example that was outside of all of the other points of data than it would be for them to pick out an example that's in the other point of data, because it might get confused. So now what we're going to do is we're going to create a 3D model, and I did actually get this program from sklearn, but I had to modify it to be able to use it with the E. coli. So I had to do some work on it to get it to work. So one thing I had to do is I had to put the 8 classes into a label encoder, because this E. coli doesn't want to see an object, it wants to see numeric. So I had to label encode my target. And then so we create our 3D diagram, and then we do that by setting PCA up. PCA equals decomposition, PCA in components equals 3. So since it's 3D, we have to have 3 in components. We PCA fit X, X equals PCA transform X. And then, so we set our labels up. So CP equals 0, IM equals 1, PP equals 2, IMU equals 3, CM equals 4, OML equals 5, IML equals 6, IMS equals 7. So we set our labels up. And then what we do is we have to set our actual 3D up. So we've got our 3D of 0, 1, 2. So you've got the 0, and then you've got the 1 is plus 1.5, and then you got the 2 is, and then you've got the name, and then you put some other coding in there. And so I didn't have to set the colors up like I did in the last one. And then you just set a scatter plot up, and you print show, and there you go. That's your 3D diagram. And I did get this diagram from sklearn, but I did actually have to modify it to actually get it to work. So there's your 3D diagram. If you want to know how the sklearn examples fit into the space in your computer, then that's showing you how to do it. So that's it for this program. It was just a short little program, and I'm going to be making a blog post on it and calling it Python in plain English, because it's just a little Python trick. So like when you're writing your programs, if you want to impress people, you can put your classification target into a 3D graph, and I'm sure it'll impress people, and they'll think, oh wow, you know. So if you like my video, please like, subscribe, and share. If you like the work I do and want to make a donation, I'll leave my email address to my PayPal account in the description box down below. And thank you so much for watching my video, and I look forward to making other videos for you.